carbon footprint was the main or primary concern for lowering environmental impact. Now with circular economy, we're more interested in how can the materials that we're choosing have a much more circular path. Thinking about their initial creation as raw materials, through design and production, through to use, and then at the end of their life, where can they go next? Is there a second or third life for them? Our vision when it comes to reducing environmental impact and waste has always been design and materials. Design so that the product is efficient, uses a minimal amount of materials, but also how do we then take the product apart so that then the individual constituents can then be recycled, reused again. For many years, the perceived wisdom was that the consumer was not willing to pay extra for sustainability. And I would have agreed with you perhaps 2 or 3 years ago. But now, the new generation of consumers really are willing to spend that extra dollar to learn more about the product, to align their values with the brand's values. So they are willing to spend more and also to consider more about what your product is made of, how it's made, and the journey it's taken to get to them. One great example has been Allbirds. Its use of bio-based materials, things such as bamboo, such as castor oil beans, and also sugarcane, has meant that as part of its brand value, it's been able to promote these sustainable choices. Consumers have very much responded to this, and even the manufacturers of the materials themselves have actually seen increased market share as a result of their materials being incorporated in these shoes. So given all this new information on sustainability and circular economy, what can a brand or producer do next? Well, of course, we would love to help. For us, it's very much about education. Your consumer is going to be a lot more educated about this, so it's imperative that you are too. What are some of the new materials out there? What are some of the new processes that you can use that can reduce environmental impact? Overall, what are some of the other brands doing that you could perhaps take from and learn from?
So Nature's Fresh is a producer of fresh pineapples. Today we have about 300 hectares of pineapple plantation. Looking at how much pineapple leaves are left to decompose in our farms and knowing that our barong Tagalog can be made from the same material we leave in our fields led us to believe that this waste can have the potential to be more than just an organic fertilizer. It compelled us to be more environmentally conscious as we plan to engage in more sustainable operations.
Nahuman na among harvest dito nga area. So dinhi na pod ang harvest. Himuon na mo ma'am. Kolektahon na mo pag naay order. Makadugang sig income sa mga tao. So madako-dako ilang kita kada adlaw. Para gihimo siya atong papel dayon katong murag plastic sa to cup.
The Piñapal project addresses the agricultural waste that is from hectares and hectares of pineapple land that we have in the Philippines. As one of our biggest exports are pineapple fruits, we wanted to provide also an opportunity to look at the other elements in growing that pineapple to provide additional livelihood to the farmers, additional revenues to the farmers, as well as maximizing the waste that is an output or an outcome of the pineapple farms and the pineapple plantation, and provide a new material that could maximize this agricultural waste.
Our role in this project, Piñapel, is to produce the handmade paper. From the time we receive the pineapple leaves, which are delivered to us from Bukidnon, we are going to sun dry it and then remove all the debris or dirt so that we collect the best shaped pineapple leaves which have no contamination. So we remove that in order to arrive at a very clean pineapple fiber.
The materials research done trials and experimentation to convert discarded pineapple leaves into paper sheets. We did the process by size reduction of discarded pineapple leaves, then pulping, reinforcement through mixing of reinforcing solution, and then molding of paper sheets and drying. And then we were able to convert the paper sheets into various secondary packaging applications with IdeaTech's assistance.
The Design Center of the Philippines contacted our company to become the converter and collaborate with the project. Since our company's aim is to be sustainable, appropriate, with the mission of the company to be pro-environment, pro-SME, and pro-branding. Piñapel paper stands out from the papers that we are using right now because the raw material for the piñapel really comes from waste that are gathered locally from the pineapple plantation. So just thinking that when you use that paper, you somehow help the farmers, you eliminate the waste, you upcycle the material into something useful.
What we also wanted to show through this project is really the Filipino value of malasakit, or the compassion on like what we do with the earth, what we do with our resources, as well as how do we provide a unique voice, a unique design perspective in a global discourse of design. It's really a testimony to circular design. So circular design and Piñapel is about, it's not just about what you take away from the soil, but it's actually what you can put back into the soil to make it richer and to make it better for future generations.
Packaging is one of the areas where sustainability is key because it's often a material that doesn't get used very long. So it needs to transport the product, but once you've got it into your hands, you no longer need the packaging. One client, US-based, was trying to improve the overall sustainability of its packaging. They were using flexible packaging. Transparent was also printed onto, that was heat sealed. In order to solve this problem, we actually came back to them with a 100% recycled version. Not easy to do with transparent and printability and heat sealability. So that material came from a newly developed technology, and we were able to have an immediate drop-in solution. So they were using material A, which wasn't recycled. We offered them material B, 100% recycled content, easy to print onto. It matched all of their needs and was at the right price point as well. And within probably a couple of months, they're able to import it directly into their process using their same machines and come out with an identical packaging material with a solution that has significantly lower carbon footprint.
Hello, everyone. Good day, wherever you are in the world. My name is Carlo Delantar, the head of circular economy for Gobi Partners, and today I am moderating today's webinar called Plastic Waste in Our Oceans. As the head of circular economy for Gobi Partners, my role is to look for innovation and solutions for the region, and the goal is to help transition the world towards a circular economy. So what does that mean? Asia in general is one of the largest region for population, and also a lot of waste is being translated to that. So where do we go from here? How about the Philippines? And I'm super happy to have this conversation with our speaker, Dr. Andrew Dent, in a bit. But before that, I'd like to thank this webinar brought to you by the Design Center of the Philippines in partnership with Material Connection, the leading global platform for material innovation and solution with its headquarters in New York City. Today's broadcast partner is the Philippine Trade Training Center. Thank you so much, PTTC. And just context here, if you haven't been to the Design Center of the Philippines, there's this huge wall installation called the Innovation Wall. And this is from the Material Connection. And having Design Center of the Philippines and Material Connection having that partnership, I said to myself, oh my gosh, what a great initiative. You're seeing so many materials being implemented in the world. Can we apply it in the Philippines? Can we use it in the Philippines? Or can we draw inspiration for these materials for the Philippines? I urge everyone here joining this webinar to check it out, maybe after the pandemic, maybe, but this is really one of those initiatives coming out of the innovation wall, and how what we could do for this webinar, specifically on plastic waste in our oceans and in general, material innovation. So as an advocate and champion for the circular economy, I thank Design Center and Material Connection for arranging this discussion on plastic pollution, especially for a country like the Philippines, not only because of the plastic pollution that we generate, but because as an archipelagic nation, we become vulnerable to marine plastic pollution, not necessarily generated by our own borders. So I'm really looking forward to our conversation today and hoping to deep dive into this very critical issue and gain a deeper understanding, like what are the kinds of plastic wastes are out there in our oceans? How do these plastic wastes affect the marine environment and us humans? And more importantly, what should we do about it? So to get things started, for everyone that's joined already, just wanted to ask some initial poll questions to our audience. And by now, you should see a poll question. And the first poll question would be, if age is a state of mind, which category best describes your age right now? First one, A, cheeky child, B, tormented teen, C, mad midlifer, or D, caring grandparent. We won't judge. This is just a poll. I myself, I feel like I belonging to the category of Tito. So I will go for somewhere close to a Tito. Awesome. Thank you so much for your participation. On to our second poll question. The question is, hand on your heart, are you using a plastic cup right now? Hand on my heart, no. Nothing wrong with using a plastic cup. Thank you so much. And lastly, for the last poll question, how much plastic do you consume in a day? I think this is a really great transition towards our talk, really thinking about, do we even reflect how much plastic we use in a day, how much we use in a year, in a month, and hopefully this gives us a bit of understanding and context of why we are here today. And obviously you're here because you care about the planet. So how much plastic do you consume in a day? Never, very minimal, or a lot. So later, before we have our fireside chat with Andrew, we will show the poll results. But for now, I'd like to introduce our speaker, Andrew. Today, we are joined by Andrew Dent, the Executive Vice President of Research at Material Connection and Chief Material Scientist at Sandow. Andrew has helped hundreds of clients develop or improve their products through the use of innovative materials. A leading expert on sustainable materials, his insight has played an important part in creating a new generation of more sustainable products. Andrew also oversees the materials knowledge of the Sampling Service Material Bank. He is a frequent speaker on sustainable and innovative material strategies, having given 2 TED Talks at TEDx Grand Rapids and TED NYC, and is the co-author of the Material Innovation book series which includes packaging design, product design, and architecture. A leading expert on sustainable materials, Andrew has played an important part in creating a new generation of more sustainable products. But before we start the webinar, I would like to remind everyone that if you have any questions, please don't hesitate to comment down below, whether you're in Zoom or on Facebook. We'll take them down so we can revisit and discuss later during our fireside chat with our speaker. I'm super, super honored to have Andrew here, and hopefully we all have great insights from this and take action after the webinar. So without further ado, Andrew, you can take the stage now. Thank you so much.
Thank you, Carlo. Can you hear me okay? Wonderful. Okay. Thanks so much for having me. Design Center of the Philippines. I appreciate the time you're going to spend with me today. My presentation is going to take about 45 minutes to an hour. My hope is that during that time, I can sort of educate you a little bit about what the problem is in terms of what the challenge we have in terms of the plastics in the ocean. Also, some of the ways in which we are trying to reduce that. Are there ways in which you can help? Are there ways in which the Philippines specifically can help? And what are the paths forward? How do we find solutions to this current challenge? Yeah, I'm going to do a PowerPoint presentation. I'm going to share my screen in a little while. But what I would love for you to do is to, there's going to be a lot of information I'm going to be sharing during this presentation. So I want to make sure that you're paying attention as much as possible. I would love to have any questions that you have. As I see them going through the chat on the right-hand side of my screen. If there are some that are relevant that I think I can answer quickly, I will do so. So, I want to make sure that you feel engaged. So I'm going to keep an eye on those as I'm going through the presentation. So do feel free to ask those questions. Ones that I don't get to, Carlo and I hopefully will chat about those after the presentation's finished. We're going to make sure we have plenty of time for the question and answer. I think we've got about 20 to 30 minutes to do that, because I think a lot of the value can be had through that discussion, through the questions that you're asking. We want to make sure that you feel included and listened to. So don't be afraid to ask the question. We will promise we will try to get to try and get to all those questions that come up, either immediately or with Carlo afterwards. Okay, so let me share my screen and let's get going with the presentation. Okay. Hopefully you can see plastic waste on our oceans. There's me, Andrew Dent, working for a company called Material Connection. So for those of you who don't know who Material Connection is, we have for the last 20 years been helping a range of different clients find innovative and sustainable materials for consumer products, for cars, for architecture, but everywhere that we as consumers interact with. So think about your daily sort of commute or your what happens during your day. All the materials that you see and touch, whether they're in your home, at work, whether they're out on the street, we're working with those types of brands and companies in order to make those materials more sustainable and innovative. We have libraries This one is in North Carolina. We have an innovation wall in the Philippines. As Carlo said, I would very much recommend you go and see it. That wall is updated on a regular basis to show you the most innovative and sustainable materials from around the world. It's a great education resource. And also there you can have access to our online database, which houses 10,000 of those materials that we've been sourcing over the last 2 decades. Okay, that's enough about material connection. Let's get into the workshop. Okay. So I want to go through 5 different sections. The first is understanding the problem. Now, we've all been through a lot of the images. We kind of know what we're up against, but I kind of want to put that into some basic numbers. I want to talk about circular economy because I think really, and I'm sure Carlo would agree with me on this one, it really is the only way forward. I've talked with Ria as well, who's head of the design center, about this. How do we sort of approach the circular economy? The Piñapel video was a great example of how you can take materials that are sourced locally, produce them, and then use them locally in that circular idea. So that to me is a great example of circular economy. Then talk about how we can reduce the plastic waste, right? To go through 4 main areas: reuse, burning. I know burning is a contentious issue, but I want to talk to you about that anyway. Recycling and biodegradation. Those are really the 4 ways in which we can reduce the plastic that's currently being produced and actually out there in the environment. Of course, being all about materials innovation, I want to show you some latest material innovations and go through those, and then also sort of round it out with what some of the takeaways are from today. Okay, understanding our problem. So the whole area of a sustainable ocean economy, according to people who know about these things, it's 7 different areas. And as you can see, obviously improving wastewater and stormwater management, making sure that the water that goes into the ocean is as clean as it can be. 6 and 7 includes coastal zone improvements, the stuff that's around the actual ocean, and also local systems for safe food and water. It's fair enough. But it's the 3 in the middle, the 3 in blue: adopting green practices and new materials, practicing radical resource efficiency, and also recovering and recycling, I think, are the most important. So what do we mean by that? So we want to try, the organization is recommending that we ban sort of large and hard to manage substances like expanded polystyrene, limiting certain chemicals, which we know to be of concern, and also developing new materials that maintain the desirable performance characteristics of plastics, but not the problematic ones. Great example was the Piñapel. There you've got an ability of a natural material, which is not a plastic, performing the insulation properties which would normally be expected from a plastic foam. The second one is radical resource efficiency. Can we actually try and reduce the number of materials that are going out there through bans or restrictions? The UK has a great example how they've reduced by about 9 billion fewer plastic bags since 2015. That's a huge number and a great way to reduce that waste. And also just sort of recovering recycling. How do we implement extended producer responsibility rules? How do we get people to sort of participate so they can help in that procedure? Okay, let's get into more specifics. We know, and this comes from the Ellen MacArthur Foundation, that there's a whole lot of plastic going out there into the world. Of the 78 million tons per year going out there, 12% of it is actually leakage, and that's the challenge we're looking at today. Plenty goes to landfill, some goes to incineration, some goes to recycling, but a decent amount of it, sorry, 32% goes into leakage. 32% of that plastic ends up in the environment or in the sea, a huge amount. And of that plastic that's being produced, I made this up myself from research. So from 2017, we're making, of the 360 million tons that are being produced, so let's say within the US, of that, only a small amount are recycled plastics, perhaps about 10%. And of the whole amount, only one slither, the tiny little bit of blue there, is bioplastics. So I think we can see there, we got a challenge that the majority of it is virgin plastics, some recycled, very tiny amount of bioplastics, but a lot of it is just from basic virgin sources. And when it ends up in the ocean, this of course is a very sobering and frightening graphic, showing that a toothbrush ending up in in the ocean will last there for 500 years. So that's, you know, many generations' lifetimes. We're still going to see plastic toothbrushes. You know, some of the stuff floats. You know, plastics such as polyethylene and polypropylene, those will float. Polyesters, polyvinyl chloride, you know, vinyls, that sort of thing, they will sink. So although we see a huge amount of plastic in these Pacific garbage patches, a large amount of it is actually on the sea floor and lasting there for 500 years, half a millennia. We're going to have plastic toothbrushes. So that's a sobering and frightening thought that we need to be considering every time we use a piece of plastic, every time we pick up a plastic cup, every time we use a little sachet. Think about it. If that ends up in the ocean, it's lasting there for at least 30 years, possibly 100 years. Okay, so what plastics do degrade quickly? Not much. I did some research, and these are sort of 3 plastics which if they end up in the ocean will degrade quite quickly. Rayon, which is a sort of synthetic silk, that degrades quite quickly. So your Hawaiian shirt is made out of rayon. Well, actually, if it ends up in the ocean, you're okay. It won't sort of stay there for hundreds of years. It'll degrade within a year. Cellophane, which is a transparent plastic, typically used to wrap things. It's got a sort of crinkliness. It comes from cellulose, so it comes from a wood source. That breaks down quite quickly. And then PHA, PHB, you'll be excused if you don't know what that plastic is. It's a relatively new bio-based plastic, and it does degrade quickly in the ocean. It's being used in some packaging applications and will hopefully be used more. It comes from a bio-based source, but the challenge is at the moment, it's only being used in a tiny number of applications. So these are really the only 3 plastics currently that degrade very quickly in the ocean. Everything else, as we saw earlier, takes years. Okay, so what is in the ocean? The stuff that's out there currently. I pulled this from a report, I think it was from the Ellen MacArthur Foundation. It tells us that there's a lot of nylon or polyamide. There's an awful lot of, and here you can see this, the difference is what the actual application is. So there's a whole bunch of fishing nets, probably the largest amount. It's relatively easy to pull fishing nets from the ocean simply because if you grab one end of a fishing net, you can typically pull 50 pounds of plastic just in one grab. A plastic beverage bottle, you pick up one bottle, you've only got ounces or not even ounces of plastic, you know, literally grams. So the challenge with the collection of a lot of these ocean wastes is that I can get a lot of nylon out of the ocean because I pull the net and I get an awful lot of material. But when it comes to the small packaging materials, it's awful tough to do that collection simply because each one individual piece is small. So it takes an awful lot of time to fill a boat full of plastic beverage bottles, whereas I can probably do that in relatively quick time if I can find a couple of fishing nets. This at least gives you an idea of what's in the ocean, the sorts of plastics that we might have available if we are cleaning out the ocean of plastic waste. Companies exist out there that are making money or doing a good job in sourcing and producing products from that waste. This gives you an idea of the size of the nets that are found. But then, yes, companies have been created that can help and are picking up a lot of this plastic, creating communities that can actually make money through this process, because there are an awful lot of products out there that are now being produced using this plastic waste. So there at least is there's the initiation of these types of companies that are producing viable products and products that comes from some major brands that are using this plastic waste. Where are some of the challenging areas? Of course, the Philippines is part of this. These are areas where it's not necessarily the materials that you've got more plastics in the ocean. It's simply that the plastics themselves are in areas where eventually they will end up in the ocean. There's a type of material called ocean bound. What that means is it ends up on a landfill that's not well controlled. It lands up in the street, lands up in rivers. And as a result, eventually everything gets washed down into the ocean. So ocean plastics are initially a land-based plastics problem. The waste that's basically left out and littering the streets, that eventually through storms, through rivers, through just general attrition, those end up eventually into the ocean. Everything goes to the ocean eventually. So that's the challenge. And it's not always that we're dumping stuff in the ocean. It's simply we're putting stuff into rivers, we're putting stuff onto the ground. And then afterwards, after storms, that all ends up back into the ocean. A quick thing on circular economy. What I class is the only way forward. For those who are relatively new to it, it's basically updating the cradle-to-cradle idea. McDonough and Braungart a number of years ago came up with this idea that any material out there in the world can go through a biological or a technical cycle. Biological means that it can go back into the earth and act as fertilizer to be used again to grow more crops. Technical means that it needs to be recycled in some way. Obviously, I can't use the materials from my phone in any sort of biological cycle. They're not going to be compostable in any way. So we therefore need to put them back into the system as a recyclable material. So from that, the idea of circular economy was born, which assumes that everything needs to go into a circle. Everything, rather than going on a linear process of you get it out of the ground, you manufacture the product, you then use the product, and then you discard the product. That's a very linear process. Circularity basically says we need to go that from a straight line into a circle. So everything that gets produced at the end of its life needs to go back into the economy in some way, through recycling or through composting, reuse, initially through reuse or through recycling or through composting. Nothing should basically end up in a landfill and just stay there. This, of course, requires a significant amount of redesign and careful material selection. And that's why a lot of design associations have been very much part of this, because they understand that through design it's possible to promote the idea of circular economy. If you design something that can easily be taken apart, that can be easily recycled, that has recyclable materials, that has compostable materials, design enables that. Because an engineer can do the basic mechanics, but designers make it beautiful and covetable, and therefore stuff that we want to use. I want to talk very quickly about the difference between circular economy and sustainability. And this is a great example between paper products and expanded polystyrene. Okay, so sustainability would tell us that the better product is the expanded polystyrene, because it overall uses a much lower carbon footprint. So in order to produce that egg container, that styrene cup, it requires an awful lot of carbon, awful lot less carbon dioxide. So as a general global warming consideration, the production of these sorts of packaging using polystyrene is better. So sustainability does that material is better because it lowers the carbon footprint. However, what we understand now is that just pure sustainability in terms of numbers doesn't tell the whole story. The reason why we would be interested in using paper rather than expanded polystyrene is that we know it can go back in a recycling bin, or if it ends up out there in the world, will eventually break down into materials that do not harm the environment. So even though at this time we're using greater carbon footprint to produce them, they are not damaging the environment they end up in. So, okay. What are the different methods we can use for plastic waste reduction? How do we reduce the amount of plastic waste out there in the world? This happens the same as me here in Brooklyn as it does at you in the Philippines. There is no real difference. We all have ways in which we can mitigate, we can reduce that amount of plastic waste. I'm going to go through 4 different sections: reuse, waste to energy, recycling, and then biodegradation. Reuse is really something that we can all do. I got an example here of a company called Loop in the US, because I think it's fascinating to realize that the Loop system, which is touted as this new way of creating a circular economy, is just what what a lot of the more efficient and more thrifty of us have been doing for years, which is to reuse any material that we come into contact with. So whether it's a glass jar that we then use as for cup for drinking water, whether it's reusing grocery bags again and again, whether it is ensuring that any product we have, if we are going to have it made out of some sort of material, that in some way can be reused by us. So the Loop system is simply kind of the same as what we used to have in the UK when I was growing up, which is the milkman. The milkman would put stuff on your doorstep in the morning. It would be 4 or 5 bottles of milk. You drink that milk, And at the end of the day, you basically put those bottles on your doorstep again, and then the milkman would collect them. So this idea of loop is that a lot of the products we currently use, can we have Loop deliver those products to our doorstep? We then use those products, and at the end of their use, we put them back in the container and they go back to the original brand. So rather than having single-use packaging, which is a scourge for us, as we know, the idea is that we can now have packaging which is a lot more durable and sturdy, made out of stainless steel, out of glass, out of much more durable plastics, and that then gets reused, cleaned, and used again. So that to us is a simple idea, which is basically just being thrifty or being sensible with the materials we use. So, and it's interesting that we're now touting this as a new idea, which we have been using it for literally centuries, the idea of reuse of the packaging materials. It's only been in the last 20 or 30 years that we've started to use this single-use packaging. Is there a way in which we can have systems which allow us to go back to their way of much more durable and heavy packaging, admittedly, but that's able to be cleaned and sanitized in a way that enables its reuse? Waste to energy. Now, in a dry run of this presentation, I was talking to Carlo, and he did mention that this is currently an area of contention, and maybe we can have a discussion about this in the fireside chat. But I at least wanted to address it as an area of waste reduction, simply because in the European Union they burn about 42% of its waste. Almost half of its waste they burn because they don't have the area to landfill it. US burns 12.5%. It has a lot more land to put landfills in. However, this is not a good, so even though it's been used a lot in the European Union and the US, this is not a good way forward. We've shown that recycling plastic waste actually saves more energy than burning it. So even though it's a nice, easy way to solve it, it's not necessarily the best. Also the challenge, of course, if you are going to burn it, there are an awful lot of emissions. We know that. It gives off an awful lot of toxic chemicals, an awful lot of carbon dioxide. So not really an ideal solution to our waste problem. However, there are two new innovations, gasification and pyrolysis, which do the same sort of idea, but end up with a much better result. I'm going to go through those very quickly. So rather than simply just taking a whole bunch of household trash and burning it in an incinerator, which gives off toxins and also carbon dioxide, there are two different ways. Gasification is a process which takes the waste, predominantly plastic waste or organic waste, food scraps and that sort of thing, and then through a process actually renders it into a fuel. So rather than simply burning it and creating the heat from that and using that heat, this transfers the waste material into natural gas. It can also be used. It can turn into natural gas. It can also turn it into other fuels as well, potentially even into the building blocks of plastics. So instead of burning it, transform it, and this is what gasification does. And it's the same thing with pyrolysis. This is a good example how, there's a company called Renewology, that is actually taking plastic waste and producing oil, fuel. So instead of burning it, with all the challenges, this process then enables us to remove all of the toxins, and those can then be safely discarded. Does not have any carbon emissions in the same way that burning it would do, but then allows it to be used as a viable fuel afterwards, and also potentially as a raw material for plastics as well. So waste to energy can be good as long as we're using processes that don't simply just burn the material and just use the heat from that. Recycling, okay. Large area that we need to be concerned with. A lot of good ways of recycling. I wanted to at least put forward the idea that more and more people are getting interested in the idea of extended producer responsibility, having the brands themselves take responsibility for the plastics they put out there. When a large brand, a global brand, is putting out plastic bottles, plastic cups, it has to understand that they need to take responsibility for that. Yes, we as consumers are purchasing those, but when we're not given a choice, when simply the only way we can consume that brand's product is through a plastic, you're not giving us much choice to do anything else. If you offered us different ways in which we consume it, fair enough. Maybe we wouldn't use the plastic. So are there ways in which the brands themselves can pay for better waste management, to take responsibility for that? And we've seen a lot of great examples where this is able to create much better waste management systems. So extended producer responsibility, of course, that requires government intervention. It requires consumer intervention to actually say, no, we're no longer going to produce, we're no longer going to purchase your product until you actually take more responsibility for the plastics you use. But at least then it's an area that has had some greater interest, just because we understand that if we're not, as consumers, if we're not given a choice, if we're not able to choose between plastic or something else, and we're going to choose plastic as we have another choice, then I think that to a certain extent is responsibility of the brand itself. And also, countries that typically would have taken an awful lot of our waste, let's say China, is no longer doing it. There's been a lot of challenges with the fact that China is no longer taking lower quality waste. So we now have to be a little bit more careful about what we do with it. So it's a global, it's an initiative called National Sword. A lot of companies that were making, their livelihood out of shipping plastics for recycling over to China are no longer able to do it. So therefore, we need to find better ways of recycling, more effective ways to solve that problem. Okay, just some basic idea of what we're recycling at the moment in the world globally. There's a fair amount of aluminum and other metals are recycling. So if we're using for packaging, if we're using aluminum, there's a whole bunch of recycled content out there. So if I wanted to use recycled materials in my next product, certainly I could use it out of aluminum, because there's plenty of recycled aluminum out there. Glass, there's very little. The majority of packaging, even though glass is recyclable, very little of it ends back up into more packaging. So the glass tends to be put into roads. It tends to be used as an aggregate or an addition to concrete in some products. So glass, although it is recyclable material, doesn't tend to get put back into packaging. Paper, there's a whole bunch of recycled paper out there, and we should use that whenever we can. And these, from the plastics that are typically used in packaging, we have a lot of high-density polyethylene, a lot of polyester, PET. The rest of it, though, is kind of like there's not an awful lot. So even if we could use recycled content, there isn't an awful lot of it available for things such as more packaging. So that's one of the challenges. Even though if we did recycle the material, there isn't a whole bunch of recycled content available for us to use. Okay, so companies are collecting from the ocean. We've seen that in one of the earlier slides. Products are being made out of them. They tend to be sort of relatively high cost products because of the process of collection tends to be quite expensive, but they do exist out there. There are companies that are enabling us to purchase products that are collected from near the ocean. So this is actually a very expensive bottle. The reason not being that you want to spend $100 on a bottle, but the reason basically you're spending $100 in order to spend that money to allow that plastic to be collected. So what they're doing is every time you spend $100 on this bottle, which of course very few people can, but the idea is more, it's almost like a process to promote the idea of collecting plastic bottles from entering the ocean. Of course, it's possible to have that waste collected by average consumers. If you don't have an excellent waste management system, it's possible, just outside Manila, there are initiatives which allow people to collect plastic and then therefore get food as well. So there are different ways in which we can collect this ocean waste in order to reduce it. So when producing stuff from this plastic, remember I mentioned how the individual plastics, there isn't an awful lot, but it is possible through various different processes to produce viable products from mixed plastics. So although we may not be able to produce an awful lot of packaging, food-safe packaging from this plastic waste, there are an awful lot of products that can be produced using sort of much more mixed and low-value plastics. Not every single plastic that we're collecting from the ocean or collecting from near the ocean needs to go back into packaging. It can go into different products as well. And the sorting can, if it's a challenge in making sure that everything's sorted correctly and therefore rendering it a lot more expensive as a product, you can actually just mix a whole bunch of them together and produce beautiful, viable products using those low value plastics. There are also ways in which flexible plastics are being recycled as well. That's one of the big challenges. Is although the average water bottle will have some value as a recycled material, current flexible packaging, things such as sachets and pouches and those types of materials, those are not easily recycled, but it is possible to do it. There are companies now that are creating systems and machines that can be licensed that can take an awful lot of that plastic material and recycle it into viable products. The image on the right is actually an Italian company that's producing the heads of brushes using this material. The plate on the left is a basic sort of camping plate, very, very low cost, that's produced again, the same idea. So recycling these flexible plastics through licensable machines that can do this, enabling us to take that existing waste and make a viable product and make some value from it. Materials even are used in producing sort of industrial and sort of high performance products. These eco-mats are produced from all of the municipal solid waste, the plastic waste that no one else can use. Grocery bags, sachets, pouches, other bits and pieces, closures and caps, all the bits and pieces that typically you couldn't use in any other application. I couldn't use them in an application for food packaging. I couldn't use them in a nice product because they tend to be a little bit more contaminated. It doesn't matter so much if this plastic here is a little, isn't perfectly clean and pure, because the advantage is that it's used in an industrial application. All the previous ones were what's known as mechanical recycling, chopping up the plastic and enabling it to be reused after sort of chopping it up and then melting it. The challenge, as you will see from the color of all of these other, from all of these, you've got black, you've got sort of darker colors, you've got sort of mottled and mixed colors. The challenge with recycled plastics coming from those materials is that inevitably, unless the plastic itself is clear, such as in a water bottle, it is unable to be recolored or changed in color. So you have to deal with whatever color that product is. Chemical recycling, as you can see here from the image, what it does is it enables the plastic to go back into the original polymer. So if you follow that sort of thing, so all the natural gas ends up producing these monomers into polymers, into plastic resins. That's the standard way in which plastics are manufactured. So you go from a monomer, so monomer is typically a liquid material. Polymer is a solid, and the plastic resin then allows you to manufacture into the products. You use them, they then get either reused, as we had suggested. They get recycling through into mechanical recycling, however, puts them back into the polymer. So it never actually changes the physical structure of the polymer itself. It retains the color, it retains a lot of the structure. So therefore you have limited applications for it. If I chemically recycle it, I put it back into the original monomers, put it back into the liquid. And if so, I can recycle it and I can remove the colors and the other additives. And therefore it becomes almost like a virgin plastic. So chemical recycling, which they believe is the future because it allows us to recycle the plastic multiple times. If you just, a regular bottle, it's like a soda bottle, that can be recycled perhaps 2, 3, maybe 4 times and never 100%. So my Pepsi or Coke bottle or Dasani water or Nestle water, when recycled, that will get it chopped up, get melted down and manufactured into another packaging product. But you couldn't do it 100%, so you can't get full bottle-to-bottle recycling in that way. Because by chopping the plastic up, you reduce some of its performance. You therefore need to add some virgin plastic. So every time you recycle a bottle using mechanical recycling, whether it's made into a chair or a shirt or another bottle, you have to add in some virgin plastic. Also, you're limited by the coloring. Chemical recycling enables you to put it back into the monomer, which means I can then manufacture it very much like a virgin plastic. So it has no color, it has no additives. I can then put it back and basically make it back into a polymer. So chemical recycling, I could recycle it 100 times, 1,000 times with no loss in performance. So that's the advantage of chemical recycling. There are companies currently producing products which use this chemical recycling process. And the advantage with the chemical recycling process also, I can put various different plastics in there. So this product from Eastman uses low density polyethylene, it uses polypropylene and lots of other plastics. But because the chemical recycling process, it pulls all those the polymers apart, it means I can produce good, high quality plastic out of all sorts of mixed plastics through this chemical recycling process. So it gives us the chance to go back to a virgin or high quality type plastic from these waste and lower quality plastics. Okay, so if we can't go waste to energy, so if we can't reuse it, if we can't go waste to energy, if we can't recycle it, can we have products that biodegrade safely, either in the environment or in the ocean? So what are the things in which a biodegradable material has to do? Okay, these are the 6 things which it needs to do in order for it to biodegrade safely. Now I'm talking about plastics here because paper, my cotton shirt, any sort of banana leaves or pineapple leaves, when those biodegrade, they biodegrade safely because it's part of the ecosystem. What we're talking about here are plastics and synthetic materials. So these are the 6. It needs to only break down into carbon dioxide, water, and biomass. So anything else means that I'm putting pollution out there into the environment. It has to have no harmful additives. So when my blue packaging bottle breaks down, the blue pigment has to be an organic pigment. So therefore it can also be eaten by bacteria and microbes. If it's made out of a synthetic or a non-organic pigmentation, basically what happens is the blue plastic might break down, but the additives are still left there. The blue pigment is left there to contaminate. So no harmful additives. It needs to happen within months, not years. Because as we saw, a lot of the plastics last from 20 years to even 500 years out there in the ocean. We need it to happen in months, so therefore it's breaking down into small parts, smaller and smaller parts, and eventually into biomass in the matter of months, so it doesn't contaminate our environment. It doesn't you don't have animals then going inside it or getting caught up in it. So if it's breaking down within months, then therefore it means that these things are breaking down quite quickly, enabling that, if some animal was to get caught up in it, it breaks down quick enough that it doesn't actually harm it too much. It needs to be not oxo-degradable. Be careful of biodegradable additives which claim to be oxo-degradable. What that means is it just results in smaller pieces. So my single bottle or my single sachet will break down, but it'll end up in small parts of plastic which don't break down any further. Those microplastics are currently clogging up various different ecosystems, so it can't be an oxo-degradable. It needs to be fully biodegradable, as I mentioned, into carbon dioxide, water, and biomass. It needs to be certified in some way. You need to have you need to be sure that this material actually does it in the right way and the right amount of time. So it needs some sort of certification in order to convince us, to make sure that we understand that it is actually fully marine degradable. And also, ideally, it should not affect recycling systems. A new generation of biodegradation additives can be put in there into a plastic and will happily sit there and be recycled again and again in a standard recycling system without biodegrading. Only when it ends up in the environment within certain microbes will it start breaking down. So if your biodegradable product ends up in the recycling system, it doesn't contaminate that system, because the worst thing that could happen is if I'm collecting water bottles off of the beach from the ocean, if it's a biodegradable version, if I put it into the recycling system and then it biodegrades in the middle of that system, that's a bad thing. It contaminates the whole value of that part of the circular economy. So the biodegradable additive, if there is potential to go into a recycling system, it should not degrade and affect that recycling system. Okay, how does this stuff break down? So what happens is it's typically a 2 or 3 stage process. The polymer itself is the chains of the polymer. Those long carbon chains that are the backbone of the plastic. Those get broken down by sunlight, temperature, ultraviolet radiation. So out there in the environment, if sunlight hits them, it tends to start breaking down. As well as that happening, bacteria start to accumulate on the surface of the polymer. And those bacteria secrete proteins, and they start to sort of chew away at the polymer. It's very hard for them to chew away at the full length, the fully, full polymer. So typically, if you take a plastic, it needs a bit of additional help, unless, whether if it's a regular plastic, it'll need sunlight to break down. That can take years and years and years. So if you don't have sunlight, if you don't have years and years and years, if you want to have some sort of acceleration of that biodegradation, you need to put in that additive. And that additive enables the breaking down of the polymer chains more quickly. And therefore it makes it much more edible, more palatable, more enjoyable to eat for the bacteria. So bacteria start, so the sunlight or the biodegradable additive starts breaking down those polymer chains in the right environment. The bacteria comes in, starts eating it and pulling apart those polymer chains more into individual monomers. So in the same way that chemical recycling brought the plastic back to a monomer, these bacteria do the same thing. So the biodegradable additive helps them. The bacteria do the main part of the work. They pull it apart into monomers, and eventually they consume it. And that sort of what they call assimilate it. They consume it, and it basically goes into their bodies, and they then become the biomass. So they start eating it and using it to replicate, to increase their volume, and that then becomes the biomass. So if we're thinking about biodegradation, there is a difference between those which we can promote the biodegradation by additives and those which are inherently biodegradable. These are two elastomers, two rubbers that are out there in the world that are inherently biodegradable. They come from a starch-based elastomer that will biodegrade by itself without any additive. Teratac is one, Apinat's another. So in using these rubber materials, of course, latex can be used, and that is inherently biodegradable. The challenge with latex, though, is, latex in rubber products, in foams and that sort of thing, they tend to add in a bunch of synthetic rubbers as well, which makes it a lot less biodegradable. So balloons, examination gloves, those types of things, in order to maintain their strength and performance, they tend not to be 100% latex. And as a result, they tend to not break down so easily. So even though latex is a natural rubber, can break down by itself, so a lot of the time they add in a lot of other synthetic rubbers, and that reduces their biodegradability. These two, however, will biodegrade, have been certified. So they are rubbers and elastomers that can be used as a sort of for grips, for covers and that sort of thing. They just biodegrade inherently because of their chemistry. There are other plastics which are inherently biodegradable. PLA, you may well have heard of. It's a sort of well-known corn-based plastic. It's been used for a number of years. That's often added into a plastic called PBAT for things such as flexible packaging. So these would be degradable. Now, the PBAT is added into the PLA to make it more quickly degradable, because the PLA itself, you typically need an industrial composter to degrade it quickly enough. So the PBAT improves its performance and also improves its degradability. PBS is a plastic that is used as linings for coffee cups and also for other mulch films and packaging that does degrade quite quickly. It degrades in marine environments, but just relatively slowly. So it will break down in marine environments just a little bit slowly. And as I mentioned before, the PHA, PHB, that it really is a great hope, because it breaks down so quickly in marine environments. So all of these are inherently degradable, but just because of the way they're made, what they're made from, all of them are made from bio-based sources. They degrade just by their nature. But there are also additives. I mentioned there are additives which can promote biodegradation of plastics more quickly. Timeplast, EcoPure, D2W are all additives which will be put into plastics. So whether it's a polyester water bottle, whether it's a container which in this case holds chocolate fudge cupcakes, whether it's a grocery bag or some other thin flexible film, there are additives that can be put in, and depending on how much additive you put in, will decides how long it will take for that plastic to degrade. Now, some of these, I'm not going to go into the specifics about the chemistries and about how long they take and which ones are marine degradable, etc., because that is very much more involved than we have time for in this current workshop. But go out there and research. If you simply just look marine degradable additives for plastics, the internet will give you sort of information about those. These are just some examples of ones that we've worked with and promoted because we believe in the quality of what they're doing. So these are additives which you can put into consumer products, which will then promote degradation, biodegradation, whether in the environment or in the ocean. But there are, each one has its own advantages and disadvantages. Each one will have a specific way in which it breaks down. So there's some are better at breaking down in the ocean, others are better at breaking down in specific environments. So it's very much it's not necessarily a complicated process, but certainly before you use any of these additives in any of your products, you do need to consider, okay, where is my product going to be? How do I want it to break down? Is it just marine degradability I want? Do I want to make sure that it breaks down? Do I want to make sure that it can be recycled? So the water bottle there, I'd want to make sure, and it does, it can go back into the recycling stream. So if one of those water bottles ends up back in the recycling stream, the biodegradation additive does not affect that recyclability. Only when it gets into certain environments will it break down. Okay, so I wanted to go now into some materials to look out for. Just some innovations, and I want to talk about some of the ways in which we're seeing materials that can hopefully reduce our overall impact on overall reliance on plastics, and if they are plastics, that will break down easily and be viable if they end up in the ocean. It is possible to make plastics that are water soluble. There is you've probably seen it through certain detergent advertisements. There are water soluble packets and they're called Tide Pods and other things like that, where the plastic itself is water soluble. The majority of those are actually coming from petroleum plastics. So the Tide Pods are using a petroleum-based plastic, which is water soluble in their packaging, which is good because it means it won't end up there in the environment, but it's bad because it's using a petroleum or a fossil fuel-based source. Lactips is an example where they're actually producing the same sort of water solubility, but from plastic made from casein, from spoiled milk. So it's a waste material used then as in a packaging application that then is water soluble at the end of its life. So that gives a better, a more viable alternative to the idea of water solubility. There are paper-based products which are sort of more high performance. There are certified compostable, but also recyclable at the end of its life in the paper bin. So, I think we need to think beyond just the basic idea of paper. Are there alternative ways in which we can improve the performance of paper so it has some water resistance, some sort of more sort of fabric-like performance? So in applications where paper, in a wet application where paper would simply just break apart, there are solutions such as this, which are cellulose fiber based. So coming from a cellulose base, whether that's from a wood or from cotton or from grasses, it's then manufactured in a way such that it has much better water resistance, so it can be used in wet applications, but then still composted at the end of its life or potentially recycled with other papers in the paper bin. This I thought was an interesting one because a lot of the challenges we have is with that flexible packaging, the stuff that the sachets, the thin flexible pouches that at the moment aren't easily recycled. There's very little value for those plastics other than just for basic sort of waste collection. It's not really possible to use those in recycled solutions. This is a great example because it shows that with sufficient sort of time, admittedly, it's a 10-year research and development, so not a quick solution, admittedly, but the advantage here is that it's a flexible film Now, with toothpaste, you need multiple films in order to make sure that you have a good barrier. It doesn't degrade, because often you're using chemicals in there which could degrade plastics. It doesn't lose its odor. It makes sure it's fresh. So in that case, they need to have multiple layers. Typically, toothpaste tubes have 3 or 5 layers, often with an aluminum layer as a barrier, but other printable layers and also food-safe layers for the inside of the container. This version used all the same plastic for all of those different barriers. So using polyethylene, which is a lightweight, flexible packaging plastic, they use different versions of it, different copolymers and different sort of chemistries, all the same polyethylene, which enabled them to get the barriers that they needed. So it was a 3-layer polyethylene. Because it was used, because it was all the same sort of basic chemistry, polyethylene, it meant it can be recycled with other polyethylene products. So rather than having that multi-layer, which meant that you couldn't really recycle it at all because you had different types of plastics as well as an aluminum layer, this solution allows you now to recycle your Colgate toothpaste in the same bin as you would other polyethylene plastics. And one other great thing is that they actually allowed their competitors to use the material itself. So they took years to develop it, but they're actually putting it out there. And if you're a different toothpaste manufacturer, they're saying, yes, use this plastic because we believe it's the right thing to do. Using paper instead of plastic, in this case, kind of similar in the way that I guess you would with a coffee cup, where you've got the majority of the material, which is made out of a paper-based material. What these tubes will typically be crimped at the end. So think about your average toothpaste tube, for our previous image. That originally was a tube very much like this paper tube, but it was crimped and closed at the top. So here they haven't yet closed it, but they would do. So this would eventually be filled and then closed at the top and crimped. So, so using majority paper, but with a very thin layer of a polymer, which can be separated as part of the recycling process. So in the same way that there are ways in which paper, Starbucks and other coffee company cups can be recycled because the polymer layer is pulled off during the recycling process, the same thing can happen with these paper-based tubes. So removing the need for the multi-layer tube altogether and using a predominantly paper-based tube is a very good way to go. This one is, again, using the same idea. It's, again, using predominantly paper with a very thin barrier layer. And this company, Pabocot, yes, is basically, is producing this paper bottle for a range of different companies. They've had partners with liquor companies such as Absolute, with beer companies like Carlsberg, and also with beverage companies like Coke. They have these partnerships, and the film itself needs to be slightly different depending on what they are actually containing, but it does have enough performance to contain carbonated beverages. So here you have a predominantly paper container, can go into the recycling system, is coming from a predominantly bio-based source, pulp fibers. Ultimately is an improvement on our existing glass products, based simply because it's lighter weight and has a bio-based source, but then can be recycled at the end of its life. There are foam alternatives. We talked very early on about the concerns with expanded polystyrene, because the reason why expanded polystyrene is so bad is because if you recycle it, it's so lightweight, the value you get from that recycled material is so low. Think about filling an entire truck full of expanded polystyrene. You've probably only got a few pounds of plastic there. So the amount of energy it would take to recycle that just isn't worth it. The stuff is so lightweight that once you melt that down, it becomes such little material, there's no real value in its recycling. So that's the reason why we don't like expanded polystyrene, and also it takes decades, even hundreds of years to break down. There are alternatives. This is a bio-based foam that is compostable, has similar properties to the expanded polystyrene, but will break down in months rather than in decades. So that has but the challenge, of course, with this is that it doesn't really fit within the recycling stream. It has no real sort of value after afterwards. It is biodegradable, but the product itself is very large volume and is sort of a blight on the landscape, simply because it's so big, you know, it has such a large volume for the amount of material used. You know, we've seen the use of things such as mushroom type packaging as an alternative. And that I think is viable. The challenge has been with the mushroom is that because it's a food source, a potential food source, it's hard to get it shipped globally. You know, the challenge is it's, you know, there are restrictions to what you can ship globally. So packaging that comes from a fungi has had challenges with going across national lines. So there's still potential for the use of things such as mushroom packaging as an alternative to expanded polystyrene in certain applications. But typically it's challenging if you're going to ship those products globally. There are compostable metallized films. This is an Israeli company that's using compostable resins. And the reason why the metallized film is compostable is because the aluminum film itself is so thin that once the plastic breaks down, the aluminum just ends up in the environment. And a small amount of sort of micron-sized pieces of aluminum does not affect the environment at all. It's out there in the world anyway. There is, you know, the aluminum as a sort of very small particle is out there in our environment already. Aluminum is very abundant in the Earth's crust. So it is possible to make metallized films compostable because the plastic itself will compost and then the metallized film will simply just disintegrate in a safe way. So they can get through past the compostability certifications that way. So it is possible to create those barriers with materials that will compost relatively quickly in a matter of months, rather than having a flexible multi-layer that's out there that lasts for years and decades. I mentioned PHA plastic earlier. It's one of those plastics which is great because it's bio-based, but also degrades quite quickly in the ocean. This one uses vegetable oil as a raw material. So we're starting to use, and the way it's produced is the vegetable oil is eaten by bacteria. So this is a plastic produced from bacteria. Bacteria will feed on certain sugars and oils and fats, and will then convert them into plastic. So the bacteria themselves produce the plastic, which is an odd way to think about it. But yes, the bacteria, through their natural process, they secrete out a plastic-like material, which is this PHA. So the system is that you take vegetable oil, you feed it to a bunch of bacteria, the bacteria then eat that and propagate, and then the stuff they secrete out is then taken away and then manufactured into this plastic. So this has some great potential. The performance of the material at the moment is not as good as our current range of commodity plastics, but it's getting there. There's a lot of companies out there across the world. There's one in Malaysia that's doing some great work in developing plastics from this type of waste vegetable oil. In that case, they're using waste palm oil. So they're looking for partners to further sort of commercialize it. But the idea is to take an awful lot of the waste palm oil, use that for the bacteria to eat, and then produce this PHA plastic. PHA plastic is marine degradable. It can be used in films. It can be used in molded plastics. It has some great potential. Similar in properties to some polyethylene. So in anywhere where you're using a polyethylene, you have the potential to use this type of plastic instead. Okay, so before we get into the questions, I know I've gone through an awful lot. Let me stop my sharing my screen. Okay, there we go. Before we get into the questions, I went through a lot of information. What I want you to take away from this is that there is not going to be one single solution to this. It is going to be a combined effort. That combined effort requires us as consumers to think carefully before we ever use a plastic product. Before you ever get to the point of needing to clear up the plastic waste, if we can reduce the number of plastic products we interact with, so much the better. Look for solutions that are plastic free. The Pinapel is a great example. How do we find solutions which are simply just plastic free? So it comes from us as consumers making considered choices. It comes from us from designers, thinking about circularity, thinking about their material use? How do we ensure that before we even get to that point where I need to worry about recycling and reuse and biodegradation, how do I ensure that through my design, either I'm not using plastic at all, or that plastic then it enables a much easier either reuse or recycling or biodegradation. So as a designer, have an awful lot of power in order to make those considered choices, understand what materials you can use, understand what the application is. What is my product going to be used for? Where is it likely to end up? And then therefore, a result of that sort of likely end of life, make the material choices accordingly. So it isn't a one size fits all. It's not everything can be recycled. Everything needs to be biodegraded. Everything needs to be durable. It depends on what the application is. So the designer needs to think carefully about that before they even put pen to paper, before they even start thinking about concepts. What is the end of life for my product? How can I ensure that it has the chance to become that circular? So designers need to be more considerate as well. Brands and manufacturers. The extended producer responsibility. How do we ensure that our brands take responsibility for the choices they have made? Because the choices they have made affects us as consumers and also the environment as well. So the brands themselves need to be considered. The government as well. The government can make choices. The example of the UK government, which banned plastic bags and therefore reduced sort of like millions of tons of plastic waste out there in the environment. So the government needs to get involved as well. And also there are there are institutions and organizations that as well can promote sort of safe and better use of these types of materials. So but for all of these, the basis is material choice. Everything that happens, everything that ends up in the ocean was a result of a material choice. So the basis for all of this, whether it's consumer, whether it's brand, whether it's designer, whether it's manufacturer, whether it's NGO, all of them need to consider about the materials and what the impacts those materials will have. And that's the reason why we always are interested in material innovation, is that through material innovation, through material changes, you can affect every single one of those decisions. You can affect every single piece of product that ends out there in the environment is based upon a material decision initially. So that's kind of where I want to. It's a combined effort. It requires educating yourself and understanding what choices you're making. It requires potentially collaboration as well. The Colgate was a great example of how the company realized that the problem was bigger than themselves. So innovations need to be shared more widely. You need to collaborate, because just consumers, just brands, just manufacturers, or just the government is never going to solve the problem. It needs to be a collaborative, combined effort in order to solve these problems. Thank you. Hopefully that's been a value to you, and I'd love to take some questions with Carlo as well.
Awesome. Thank you so much, Andrew. That was a very informative presentation. We have a lot of things to talk during this fireside chat, and I'm glad you got fairly as detailed as possible and as simple as possible to explain where we are currently, how do we tackle plastic and the innovation. So your I could say your presentation was also fairly circular and holistic. Okay, Wylab, I do have some thoughts, and if you want to take a pause for a while we do a few things, but I think Andrew did an awesome presentation, most especially on the high-level general aspect of where circular economy is, and most especially on educating us on, what it means to have plastics in our economy and how we can tackle the future of plastics. Before we start our fireside chat, I'd love to share the results of the poll question. So at least for us, Andrew, we have a pulse of where our participants are at regarding our question. So if we could have the results brought up. Awesome. So for the first one, we have a lot of midlifers, and usually the mad midlifers are always passionate about, getting things done. So I'm glad we have these participants, and of course, we have a very broad and holistic demographic during this time, and we really appreciate you guys staying in. I know it's already 7. Andrew's time. What time is it now in your place, Andrew?
It's now 6 in the morning.
6 in the morning. So good morning to you. Good evening to us. Thank you so much for your time. And the next poll: are you using a plastic cup right now? Majority are not. So that gives us a indication of a bright future that we're seeing. So, it always starts with us, and hopefully everybody around us starts also being inspired to do the same thing. So the last poll question. Okay, how much plastic do you consume in a day? Very minimal. I guess, very minimal could be relative for anybody joining us this time, but I think that's good to know that we're a bit critical on where we are when it comes to individual plastic consumption. Thank you so much. So for the fireside chat, Andrew, I'd love to keep it light, informative, and straight to the point. We do have some questions I've been trying to organize while you were speaking. So we'll put it in 3 chunks, and I know we have around 30 minutes for this whole thing. So we'll try to make it. We'll try to accommodate as much questions as we can. So we'll start with the 3 areas that we're going to talk about is first is the high level concept of where we are currently with plastics. Mm-hmm. Plastic waste too, and then the second one would be more of the Philippine centric. Let's go a bit more local. And then lastly would be our fire round, which is straight to the point answers. And this is more of the general questions. So shall we start? Are you ready? Have you drank a sip of your water?
I have. I'm ready. I'm ready to go.
This is your morning workout. For us, it's like our dinner knowledge time, Awesome. So first question. Due to the COVID crisis at the moment, carbon emissions have been reduced by more than 4%. Many wildlife markets around the world have been shuttered, and air quality in some places has slightly improved. However, pandemic-related non-recyclable materials such as takeout plastic containers and masks, and maybe 12-12 and 11-11 shopping sprees that are happening, 30% more waste has crept into our oceans. How can one address plastic pollution and feel that you are really making a difference?
I think it does initially. It does start with the consumer, with us personally. I think the poll question you had, the last one, I think that was interesting. People saying they have very minimal use of plastics. I always recommend that people, if you're ever interested in going on this journey, what you need to do, you need to take perhaps a day or even better a week, and actually just collect all of your plastic. Because I think a lot of us don't realize how much plastic we are using, how much, it's very easy to sort of forget the number of different times that you used a bit of plastic and threw it away, so I think it starts with us as consumers. We need to be more considerate. We need to consider that every single material choice is going to have a consequence. The whole presentation was about how do we reduce the amount of plastics, but ultimately it is us as consumers who are doing it. The majority that we see out there in the world. So it has to be. And I feel like the choice has to be made by us as parents as well, by us as educators. Every single time you see an example, you need to call it out. Every time and you need to also lead by example. So I try and teach my kids, but I don't try and teach my kids just by verbally. I also try and show them that we've lost the value in plastics. Plastics are an engineering marvel and should be treated a lot more respectfully than we are. The idea that we just take a piece of plastic and just throw it away, I think is not fair on the plastic itself. It's an engineering marvel. It's been able to solve great problems for us. So I think it has to be us as consumers, because hoping that the brands will solve it, hoping that the government will move, because governments tend to be relatively slow. Hoping that the manufacturers are going to change from. Ultimately, it's up to the consumer, because the consumer has the most control. If I stop purchasing from a brand, if I decide every single bit of plastic, I'm going to make sure that I treat carefully. I make sure I recycle it when I can. I try and make sure I discard it carefully when I can. I go through, if I can put it into a more sort of generalized waste management system, I do that. Unfortunately, it has to be us as consumers, because we're the ones ultimately that are at the sharp end of that. So I think educate, learn, lead by example, and just be aware of that we are as much a part of the problem as anyone else.
Yeah, and that's a great segue to our next question. And you explained pretty well that this whole thing is really a systemic issue, right? If
Yes.
there's no demand, then the supply won't provide it. And
Mhm.
if the demand is looking for new alternatives or innovations, then of course the suppliers or the producers will have to innovate, right?
Yes.
So the demand creates innovation, and really making sure that the economy looks into that, it really creates a lot of difference. So it is true that it's power to the people. So
Mhm.
moving towards systemic, the current systemic issue, multinational food and beverage companies are the main contributors to the world's plastic waste. According to a recently released global report based on a massive brand audit by green groups across 51 countries. In the Philippines, it's Coca-Cola, Nestle, Universal Rubina, Unilever, Liwewai Holdings. So how can we work with these companies to reduce their use of plastics? And I think I'd love you to touch on, I think there's always this issue where plastics is the enemy, but when we talk about circular economy, how do we can't abruptly just cancel out plastic, right? Like how do you see this, especially in the Philippine side, to make sure, especially when we're affected as much as we see, right? I'd love to hear your thoughts on that.
Yeah, I think the simple choice is don't buy from those companies, but that doesn't solve the problem, because if you want to consume, if we're in a society which allows open consumption, you could say just don't buy. The companies themselves are working hard. The challenge always with a multinational is that it's kind of like a large tanker, a large ship. It cannot turn quickly. And what we've seen is, I think, the development of smaller companies, local companies that can produce a solution where they can innovate a lot more effectively. I think I think it's unfair to say just don't buy Coke, don't buy Nestle. But you know what? I think producing a viable product on a local level, it means that when you do purchase that product, you have much more influence over it. So I think I think the more local production of products might be a viable way of doing it, because I think these companies, although they have good intentions, although they spend millions and millions of dollars in research and development, the ability for them to change is very hard. Like we've seen them go towards biodegradable or bio-based plastics, and now we're trying to make now they're plant bottles, but they're still out there in the world. They're still they realize that recyclability is better, but how much of those plastic bottles are recycled? Very few. In the US, it's probably 25%. I don't know what's like in the Philippines. So most of those bottles end up out there in the world. So I think the challenge is with these multinationals is that it's, in order to maintain their profitability and keep their shareholders happy, they can't do much of a change. There's no real innovation, no real radical innovation. That has to happen from smaller brands, smaller companies. So I would recommend, as consumers, seek out the smaller brands, maybe figure out the ones which are doing more radical change. Like the Piñapel is a great example of sort of how if a smaller brand could adopt that in a way that Starbucks never could, in a way that these major brands couldn't. So I think we've seen that with a lot of with fashion, with other products as well. Smaller local companies are realizing they can do a better job. They can innovate more effectively than some of the, even though you've got hundreds of PhDs working for companies like Nestle, they're unable to affect real change because they're like this big tanker that's going forward. You can't move it because they need to maintain profitability. They need to maintain their brand value, which is not going to work if you really want radical change and improvements on these plastics.
I'm gonna have you side park that thought. I have a really good question about that, but before
Sure.
that, the next question is, with so many environmental problems, how can you make people take plastic pollution seriously or make it top priority? I think this question really is rooted upon, especially in the Philippines, right? We're still a developing country. This is probably the first generation of majority of the Filipinos that are getting fairly good middle income wages, and they're trying to maximize that lifestyle and that luxury to actually use their money for whatever they want. And the culprit is really access and convenience, right? So with that thought, I'm curious of what your thought of that, especially in the Philippines.
Well, I mean, it has to come. I mean, does it not have to come through education? I mean, the idea of plastic waste. So maybe I have a question back at you. Where does the majority of the waste come from in the Philippines? Is it that consumers are throwing things away? Is it that there is the manufacturing plants are not taking care of their own waste? Where is it all consumers?
Not necessarily. Definitely, yeah. It's definitely, there's some systemic issue. Governments, the laws are not being implemented. Companies are trying hard, but also they're also, the profits and talking to stakeholders. And then consumer wise, majority of time, from my experience, either they're being greenwashed or they don't know any better. So I think there's like all different parts that are parallel and hopefully converging down the line.
Yeah, I mean, it is, but it is, as I mentioned at the end of the presentation, it's a combination. It's consumers, it's brands, it's government, it's, I guess there needs to be, I think the good thing is there's a recognition that there is a problem. Part of the one of the main challenges is realizing that you have a problem, and then you basically need to, and educating yourself and sort of exposing it in the way we are doing right now. That's the start. But then how do you take that, which is, the conversation you and I are having, how do you take that to the next step? So how do you then take it to organizations, governments, and basically have them understand the importance of the problem, understand that consumers don't want to see a whole bunch of trash in their environment, and then that then needs to be sort of, you then need to create, I guess, a collaborative effort. So how in the Philippines do you get concerned consumers, design organizations, government, brands, everyone to basically sit down and say, okay, we're all the problem. And each one of us needs to take responsibility. So how do you then, so I think that's the next step, is highlight it, understand there's a problem, highlight it, and then get together, collaborate, and work towards a solution that involves everybody.
Great point, Andrew. And I think this is a good segue on the Philippine-centric questions. And before I do, I'd love to give you context on where the Philippines is on circular economy. I fairly believe that the world was circular before the first industrial revolution happened, capitalism happened, right? We would be built on communities, a few couple of families. We would travel different parts of any part of land to forage, to camp, and when we're done, we just leave. But at the pace of where the world was before, nature could recover fast. But right now, because of where the world is, Mother Earth is actually trying to catch up with the amount of resources we're taking away from it. And to give you some good examples of circular economy, or examples here in the Philippines, our famous Filipino house called Bahay Kubo is made out of indigenous like materials made here. You could make it. It's easy to do. And if you want to move to a new place, we call it bayanihan here, where all of us actually carry, we bring it on our shoulders and bring it to a new place. It's a great example of utilizing products that you already have. The second one is, in terms of, especially on this aspect of plastic, in the Visayas and Mindanao region, we have this delicacy called puso, and it's pretty much coconut leaves woven together to create like rice packs. And so in practice, you're providing a livelihood for the local communities. Coconut trees are everywhere, and it's bite size, right? So the amount of design that was made towards doing that has been something that's culturally ingrained in us. And I think that's a great example of where the Philippines should start in terms of going back to design. Start with something that's cultural, start with something that's regional. And this brings me to the next question in terms of the Philippine-centric question is, we're still in the place where it's, poverty is still something that's still inherent in the Philippines. You can still see it. And of course, pollution comes into play as well. So I'm curious what your opinion in terms of the subject topic and how we can, tackle that situation in part with plastics in our oceans.
Yes, because the challenge is always, as you bring more people out of poverty, they then want to have the lifestyle of a middle class. They want to have a lifestyle which includes consumption. So that is always the challenge, that in increasing the number of people who have a living wage, who can then purchase, they're then going to purchase things which are then going to end up as plastic waste. And often, the challenge with places like the Philippines is that where I live in Brooklyn, I can purchase a huge container of laundry detergent. So it's one piece of plastic which can be easily recycled, which will last me for 6 months of washing. Because I have the ability to go in my car to pick it up and then bring it back and store it in my location. In the Philippines, you tend to work on much more sort of like short term. So that ends up requires plastic pouches, sachets, and that sort of things, more individual uses. And that's one of the challenges. And we haven't yet solved that problem, because there isn't the storage ability, the transportation ability, and the capital ability to purchase large volumes of any one thing, which therefore reduces the amount of energy required and makes it much more recyclable. So that is still going to be an inherent challenge with people with lower incomes, is just that inability to purchase in larger volumes. So yeah, I just don't think I'm qualified to, my knowledge is materials, my understanding about is how to make those materials better. In terms of the whole area of poverty, I think the challenge is how do we change the system such that you can get smaller volumes of whatever you need without the additional packaging. You mentioned sort of the bite size. That's a perfect example, because that material then can basically, you're not worried about discarding that material. It goes back to nature. So how do we have that? How do we take that idea of design and apply it to our little packages of detergents and other things and that sort of thing? So I think that's the challenge we have. That will be one way to solve it, because I don't think we're suddenly going to change everyone's ability to purchase large volumes of things. That's not going to happen for a while. So we have to solve that sachet problem. That needs to happen through design.
Awesome. Thank you, Andrew. And one last question, and I guess, we're looking at the outlook and what we see in the future. And, where 2020 has been a really gnarly year in surfer speak. And it really made the world stand still. And some people say, especially environmentalists, that this is the right time to actually change our ways, because we are bare bones back to our essentials, right? And my last question to you before we wrap up is, we see this outlook of, there's demand towards sustainability in the circular economy. Plastics has been one of the hallmark topics when it comes to oceans plastic, all the way to what do we do with it. Everybody's front and center on that. And we see that it's all doom and gloom when we talk about how it's connected to us. But if we look at the outlook of half of the population are under the age of 30 years old, and the Gen Zs and the millennials are actually the one generally in majority are demanding for change. So I'm curious what you think about that, and what are the roadblocks that we are seeing currently from your experience, and how can we tackle that in the Philippines?
Yeah, I think the pandemic, yes, you're right. You're so right. The pandemic has forced us to, I guess, think differently. I think it's a perfect time. I mean, yes, we've reduced our overall carbon footprint. I don't think that's going to last very long, unfortunately. But what I'm hoping is that in being forced to stay at home, and forced to consider the health and safety of our families, to understand that we didn't need to be traveling, jet setting all over the world, that we didn't need many of the consumer choices that we made. My hope is that will affect people, that rather than just going back into, we solved the pandemic and go back to our original life, my hope is that we will now think differently about the choices we made. We made the choices previously without thinking. Now we understand that there are consequences, and the pandemic is a great example of consequences of everyday actions. You know, like the purchasing the bottle of soda is a convenience, and it's a simple thing we don't think about. Shaking someone's hand used to be a thing of you know, of a way to connect with people, and we don't really think about it. I always think it's fascinating. If you watch movies now and you see people crowding at a bar or going and meeting together and they're hugging, or you suddenly what? Why are they doing that? So I think we as humans hopefully will have give things a second thought, and we'll stop thinking, well, it's easy and convenient, therefore I'll do it. I think the pandemic hopefully will make us think twice, and I think that is probably one of the best things that can come out of it. You know, I mean, the health and safety is important, and obviously the deaths have been terrible, but maybe it'll make us think twice about what we are as humans and what are the decisions we should make. And I think, you know, sitting at home for long periods of time, having a lot of time to think, and just being a lot closer to family and only having a few friends, you know, I've become a lot more considerate about any choice I make now. And I think hopefully that will be a consequence of the pandemic.
Awesome. And with that, thank you so much, Andrew. That concludes our fireside chat with Material Connections' Andrew Dent. I hope that our discussion on plastic waste in our oceans have enlightened and inspired you to address our plastic problems and be more responsible producers and consumers. Andrew, any last words before we end the show?
Just a great shout out to the Philippine Design Center. I've known Ria for years, for decades almost. It's been a great resource. We always connect, and I mean, I love the materials and innovation that comes out of the Philippines. Keep doing it. Keep doing what you're doing. It's a great resource and a great way to basically educate people. And thank you so much for having me on, and I appreciate the chance to sort of connect and talk about material innovation with you.
Awesome. So unfortunately, we have reached the end of our session today. Before we go, I'd like to thank the Design Center of Philippines for organizing this online event, our partner Materials Connection, the Philippine Trade Training Center, our broadcasting partner, and all our participants who have joined us today virtually. If you want to know more about new and innovative materials from Material Connection, Design Center has the innovation walls as well as subscription to the Material Connection database. Please feel free to reach out to the Design Center's Resource Center to get more information and access to inspiring materials and process that can be a catalyst for innovation in your businesses as well as your designs. And I mean it when I say you need to reach out to the Design Center. There's so much resource, there's so much great resources for the Filipinos, everyday Filipinos to tap into. Please make use of that. We are paying taxes for that. And it has been my pleasure to be your host for this webinar, as well as further promoting the value of circular design and circular economy. For those wanting a certificate for this webinar, we have a feedback form. A slide will pop out in a bit. And if you have any feedback, anything that you want to ask Andrew, DCP, PTTC, Materials Connection, we will be using that to further improve further webinars and initiatives that we could do together with DCP and Materials Connection. And you can see the QR code there. And also in the chat screen, please feel free to do so, especially the ones that are asking for certificates.
Carlo, one last thing. If there were questions in the question and answer session that we didn't get to, I'd be happy to take a look at those and answer them. If answer them via I could basically answer them by writing. So if there are questions that we didn't get to and you feel like there's value in me answering those, happy to do it, and we could have that available with the video as well. So I want to make sure that people at least were heard and the questions were answered. So I'm happy to spend that time and answer those questions if you need.
Yeah, okay, awesome. And super noted. We will send you all these questions, and with that, you will have a very productive coffee and breakfast because it will give you a lot of time to read and answer these questions. Thank you very much. And to our Philippine audience, have a good evening. And to Andrew again, thank you for starting your day very early. It has indeed been impressive that you can share with us all that when it's only just 6 a.m. in New York, 7 a.m., close to 8 a.m., have a great day, Andrew. Have a great day, Philippines. Thank you so much and happy holidays.
Thanks, guys. Bye-bye.